Hello, ladies and gentlemen. Today is section 3.6. We're talking about proving theorems about perpendicular lines. And the main thing we're going to go through is actually what these new theorems are, not so much the proving aspect, but more so being introduced to the theorems. And then you'll be working on an assignment involving proofs. So our first theorem, Theorem 3.8, I want us to take a look at the diagram that is represented. And we have ray G and line H, and these two angles that are formed, 1 and 2, are congruent. We know they're congruent because they have the same number of curves, which represents congruence. So if both of these are congruent, what do the measures have to be? Well, they have to be 90 degrees each because they form a straight line, they're a linear pair, and each of them are equal, so they both have to be 90. The angles are equal, and they add to give us 180 since they're a linear pair. That essentially is what this theorem says, Theorem 3.8. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So in this case, since both of these angles are equal, then the lines are going to be perpendicular because both angles are right angles. And there's a proof of this, which is example 31 on page 196. So you can always check out the proofs in the book if you're interested in that sort of thing. So that's our first theorem for today. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Theorem 3.9, very simple theorem. We know that if two lines intersect, they form a right angle. What this theorem says is that all four of those angle forms are right angles. And to do an informal proof, because the formal proof is located in your textbook, let's say angle 1 is formed and it's a right angle because these lines are perpendicular. Well, 1 and 2 should both be right angles because they're a linear pair. They should add to 180. 2 and 4. 4 has to be 90 because it's a linear pair with 2, and it's vertical with 1. And 3 is vertical with 2, and a linear pair with 1 and 4. So they all have to be right angles. They all have to be 90 degrees. So if two lines are perpendicular, then they intersect to form 4 right angles. All 4 of those angles are going to be right angles. So looking at a problem involving that, the diagram at the right, we know that line AB is perpendicular to BC. What can we conclude about angles 1 and 2? Well, first thing we can conclude is that they're both right angles. Because we know if two lines intersect and are perpendicular, all 4 of these will be right angles. So both of these are right, RT, angles. Second, since they're both right angles, we know that the measure of angle 1 and the measure of angle 2 are equal, and they are 90 degrees. And 3, since they have the same measure, they are congruent, so we can say angle 1 is congruent to angle 2. So we can tell all those things just from the fact that those two lines are perpendicular. Theorem 3.10, and again, actually some of these don't have special names to them because they're not used very often. The later two we talk about that have names because they are used quite often. This one says if two sides of two adjacent acute angles, like 1 and 2, if two sides are perpendicular, they form this right angle, then these two angles, 1 and 2, are complementary because they add to give you that right angle, which is 90 degrees. It's kind of like a linear pair. They're adjacent, they share this common side and vertex, and they form a 90-degree angle, so therefore they must be complementary. 1 and 2 should add to give you 90 because this is a right angle. That's Theorem 3.10. Not used very often, but because it comes up occasionally, it's good to at least be exposed to it. And we're not going to do the proof for this one. But looking at this example, given that ABC, angle ABC, is congruent to ABD, what can we conclude about 3 and 4? Explain. Well, if these two angles are going to be congruent, we know they should both be 90 because they add to give us a straight line. And these two lines are going to be perpendicular since these two angles are congruent to each other, So according to Theorem 3.8, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. These two lines intersect to form a congruent linear pair, so those lines are perpendicular. So both of these are right angles. So we know that by Theorem 3.8. What can we conclude about 3 and 4? Well, since they are adjacent angles, they share a common side, and they form a right angle, they're going to be complementary. That's according to Theorem, the one we just went over, 3.10. So by Theorem 3.8, we know that the lines CD is perpendicular to AB. I'm going to call it a line even though it's represented by a ray in this picture. And because of that, we can say by theorem 3.10, that angle 3 and angle 4 are complementary. So that's what we can tell from here. The last two theorems we're going to talk about, this is a very short video, is the perpendicular transversal theorem and the lines perpendicular to a transversal theorem. The names are kind of lengthy. They're not very creative because mathematicians oftentimes aren't creative. Not to say math teachers aren't creative, but just plain old mathematicians aren't usually creative with their naming of things in math. It's more practical. So anyway, for this particular picture in Theorem 3.11, we know the lines are parallel. So if this is a right angle, we know this should be a right angle because they're corresponding. That kind of just proved the theorem. The transversal is perpendicular to one of two parallel lines. It's perpendicular to the other. So if we know the lines are parallel, we already know that, like these two symbols tell us. If H is perpendicular to J, then K is also perpendicular to J. So if a transversal is perpendicular to one line, it's also perpendicular to the parallel line. That's Theorem 3.11. The next one is kind of like the converse. If two lines are perpendicular to the same line, then they're parallel to each other. That's the next theorem, Theorem 3.12. Now, we can also tell that because if these corresponding angles are congruent, of course they're parallel. And we just rephrase that when it's right angles to say if they're perpendicular to the same line, then these are going to be parallel to each other. That's Theorem 3.12, the lines perpendicular to a transversal theorem. If you're still writing these down, make sure you pause it, otherwise I'm going to move on to example 3. Now, determine which lines, if any, must be parallel in the diagram. Explain your reasoning. Well, I will tell you there are two pairs of lines here that are going to be parallel. The first pair of lines is going to be S and T, these two lines, because they're both perpendicular to Q. And if they're perpendicular to the same line, then they're parallel to each other. So that's Theorem 3.12. I would say the entire thing, the lines perpendicular to a transversal theorem, because I always ask you all to put the names, but for the sake of the notes and keeping it short, I'm just going to call this Theorem 3.12. You also could say something about corresponding angles being congruent, because these are both right angles, they're both 90 degrees, but with using the new theorems, it's Theorem 3.12. The second pair of lines that are going to be parallel are Q and P. Q and P are parallel because they're both perpendicular to the same transversal S. They both form right angles with S. So because they're both perpendicular to the same line, they're going to be parallel to each other. Again, that's Theorem 3.12. And if you wanted to, you could say that these consecutive interior angles are supplementary since they're both 90, so you could also use your consecutive interior converse theorem if you chose to. Either way, but again, using our new theorems, we're going to use Theorem 3.12, which again is called the lines perpendicular to a transversal theorem. So that's example number 3. And in order to keep the notes brief, we're going to go ahead and stop there. That's what we covered in class. Again, questions, feel free to rewind it or pause it and use this to study for a quiz or test. And I hope this was helpful.